Hi, everyone. We are going to jump into reviewing quiz 9. Let's get right into it. So we have question 1, and question 1 asks us, let f of x be equal to negative 4 raised to the 2x plus 3 power, and we want to find what f of negative 1 is. So this is an evaluation problem, evaluating um, a numerical value uh, of a function. And so what we just have to simply do is wherever we see an x in our function, let's just create some parentheses. And then inside those parentheses, you are going to fill in that numerical value 1 or negative 1. And now we just solve. So utilizing our PEMDAS, we have 2 times negative 1 is a negative 2. We have this negative 4 raised to the negative 2 power. Oh wait, it's negative 2 plus 3. This whole thing is an exponent. And negative 2 plus 3 is positive 1. So we just have negative 4 to the positive 1 power, which is just negative 4. And that's our answer. So f of negative 1 is simply negative 4. And we're done. Let's go ahead and move on to question 2. And so with question 2, we have find a formula f of x is equal to a in parentheses b to the x power, a general equation of an exponential function, and then it passes through these 2 points, 0, 6, and 2, comma, 150. So we know straight off the bat what our initial starting point is, aka our y-intercept. That's just 6. So our y-intercept is the same as our a value. That saves you some time. And then what you can do is we can use that second point, plug that into our function, and then we know our a value is 6. We can plug that in order to find what our b value is. Okay, so let's do that. And so now we're looking at f of our x value is 2. Our y value is 150. So our f of 2 is just 150. Our a is 6. Our b is what we're trying to find. And again, our x is 2. And I'll color code so you can see it a little bit clearly as well. That's the entire f of 2, our output. And then the 2 itself is our input. Okay, so now let's solve for our b. Inverse operations tells us we're going to go ahead and divide both sides by 6. And 6 goes into 150. Let's see. We know that it goes into 6 times 20 is 120. So I want to say 25 times, right? 6 times 5 is 32. Yeah. So 25 is equal to b squared. And then last but not least, we're going to take the square root of both sides. And again, our b always has to be positive. So we neglect the negative 5 and we get b is simply equal to 5. Perfect. If you forgot the whole y-intercept a value being equal to 6, that's okay. You can plug that into the function as well to find your a value. If you have f of your x value is 0 is equal to a times b, and your x value 0, b to the 0 power, anything to the 0 power is just 1. So we get f of 0 is equal to a times 1, which is just a. And our f of 0 is your output, which is 6. So then you just get, once again, a is equal to 6. And then from there, then you do this equation one more time with our 2 comma 150 coordinate points, and then you'll end up with your b value. So when we put it all together, we end up with f of x is equal to 6 in parentheses 5 raised to the x power. And that's it. Okay. So we're going to now jump to the back page of the quiz, which is question 3. And we're asked to sketch the graph of f of x is equal to 4 to the x minus 2 on the set of axes below. We're dealing with exponential functions, and so our famous exponential function e to the x. Remember how I taught you guys the trick to know what shape this looks like? It's always the undercusp of the lowercase letter e, an e for exponential. So our graph is going to look something like this. And we'll have a horizontal asymptote. But the horizontal asymptote changes if there is a vertical shift transformation involved. And in this case, there actually is. That 4 to the x minus 2 tells us that we have a vertical shift of our function going down 2 units. And you can also be strategic by creating a t-chart, a table of values, and picking good x values that you can plug into your function to find your good y values. So we'll put that off to the side as well. This one, a little wobbly. Okay, so again, 4 to the x minus 2. Let's put in 0 when x is 0. 4 to the 0 is 1. 1 minus 2 is negative 1. If we put in negative 1, 4 to the negative 1 is 1/4. Minus 2 is negative 2 and a fourth. If we plug in 1, we get 4 to the first, which is 1. Sorry, not 1. 4 to the first, which is 4, and then 4 minus 2 is 2. And then if we plug in 2, 4 squared is 16. 16 minus 2 is 14. We won't be able to put that on the graph because it's too far off. 4 to the x that has no vertical shift has that y-intercept at 0, 1, and the horizontal asymptote is at y is equal to 0. But when you have that shift down 2 units, notice how our new y-intercept is at negative 1, which means our new horizontal asymptote is at y is equal to negative 2. So fun fact, the vertical shift of exponential functions are also known as your horizontal asymptotes of the function. So y equals negative 2. This is our horizontal asymptote. And we can go ahead and put that into our graph as well. Maybe I'll put it as a dashed line. Okay. And now we can plug in, I'll put HA for horizontal asymptote in parentheses. Now we can plug in our points that we created. So let's do our y-intercept, 0, -1. We have 1, comma 2, and then -1, comma -2 and a fourth. So -1 and then mm, is that correct? Nope, that's incorrect. Right. 1/4 minus 2 is -1 and 3/4. So, little mistake. Yeah, it can't be past -2 because then that asymptote, it defeats the whole purpose. So -1 and 3/4, which is very close to -2, but it's never going to hit it. And so now let's draw out or sketch out our function. Don't forget to name our function. Our f of x is equal to 4 to the x minus 2. Put in your arrows, and then we are done. Okay. And then the very last question for this quiz, we have starting with the graph f of x is equal to 3 to the x. We want to write the equation of the graph that results from reflecting f of x about our x-axis, which means all of our once positive y values are now negative, and then also reflecting across our y-axis. So our once negative x values or positive x values are now flipped in sign. So how do we do that? Well, I'll just maybe write out the general rules really quickly. Our original function, when we are performing a reflection across our x-axis, is now going to be negative f of x. So reflect across x-axis. And then a reflection across your y-axis, we have our original function, and now our x values are flipped in value, so that goes to f of -x. This is across, sorry, our y-axis. And so if we're doing both, then both are going to be negated. We have our original function. It's going to be negative f of -x. Axes. Okay, so that's the general rule, but they give us our function as f of x is equal to 3 to the x. And so now we want to do both of these reflections. So what we're doing is we are making it both negative in the front of the function and a negative x value. And they have it in terms of y for the answer. So our final result is just y is equal to -3 raised to the negative x power. And that's it. That completes our question 4 and our quiz 9. I hope this was helpful. Let me know if you have any questions, and I will see you guys for the next video. Take care.